So this video is for Math 60, and this is for the assignment where we're working with the area of a shaded region. So two important formulas to understand before we get started is the area of a rectangle or a square is the length times the width, and the area of a circle is pi times the radius squared. So when we're talking about the area of a shaded region, let's see, I've got a couple examples here on the assignment. First example is one circle inside of another, and the shaded region is out here. So let's see what we can do to draw this. So there's the shaded region that we're interested in, and then we've got the radius of the inner circle here is labeled as 2 centimeters, and then the radius of the outer circle there is labeled as 4 centimeters. So the general idea for one of these problems where you're finding the area of a shaded region is it's like a donut, right? With a hole in the middle. So you want to find the area of the whole circle and then subtract out the area of the hole that's in there. Okay? So the area of the big circle is going to be pi times 4 squared. And that'll be 16 pi. And then the area of the small circle is going to be pi times 2 squared, which is 4 pi. So then we want to subtract out that missing piece from the area of the whole thing, and so we get an answer of 12 pi, and then if we want to approximate this, we can do 12 times, we'll have a pi button on your calculator, or you can approximate pi as 3.14. I think in either case this will turn out to be about 37.7. Yeah. So there's a good approximation for us. And that's the whole idea behind this area of a shaded region, is that you want to find the area of the whole figure and then subtract out that piece that's missing. Now there are other problems where you can sometimes add up, you can split up the shaded regions into pieces and find their areas individually and add them all together, but we don't run into those all that often. Well, I guess that's about as good as my circle's going to get on this problem. Let's see if we can clean it up a little bit. It's not too bad. Okay, so, and then the shaded region is the corners. Okay, and let's see, let's get some dimensions on here. So the way that this is labeled is we've got the center of the circle there, and that's 6 inches across. Now, be careful with these problems. Now, we need this 6 inches because that's going to be the sides of the square, okay? And so the area for the square is going to be 6 times 6, which is 36 square inches. Now, if we want the area of the circle, then we need the radius, which is always going to be half of that distance all the way across, right? So if it's 6 inches all the way across, that says that our radius then is going to be 3 inches, and the area for the circle is going to be 9 times pi. So the area of the shaded region is 36 minus 9 pi, and so now we can get a good approximation for that, about 7.7, and this will be square inches. Okay, so there's two examples to get us started thinking about these ideas. Let's start in and work with the problems in the assignment, or the even ones anyway. So problem 2, looks like we've got two rectangles here. One of them is 14 by 9, and then this is a square up here that's 5 by 5. And the shaded region that we're interested in is the big rectangle with that little square cut out of the middle of it. So again, we're going to follow this same procedure, right? We're going to find the area of that rectangle. That's going to be 9 times 14. I believe that's going to be 126. And then the area of the square is 5 times 5, which is 25. So we take the area of the whole thing, subtract out that area in the middle, and so we get 101. Let's see, do we have units on this? Meters. Square meters. Okay. All right. Problem 4 is very similar. Again, we've got a rectangle. We've got two rectangles here. So let's see. We've got our big rectangle, which is 8 by 10 centimeters. And then we've got a smaller rectangle in the middle here, which is 4 by 8 centimeters. And then the shaded area that we're interested in is everything in the big rectangle that's not in the small rectangle. So there we go. So again, the area for the big rectangle is going to be 8 by 10, or 80 square centimeters. And then the area for the smaller rectangle is going to be 4 times 8, or 32 square centimeters. And so then we'll do 80 minus 32, and that'll give us 48 square centimeters for the area of the shaded region there for number 4. Okay. And number 6, I believe we've got a circle inside a circle again. Yeah. And so let's see here. So the radius for that inner circle is 7 feet. The radius for the outer circle is 12 feet. And again, our shaded area is this region, this donut region right here. Okay? So our area for the big circle is pi times 12 squared, 144 pi. The area for the small circle is pi times 7 squared, or 49 pi. And so if we want to know what's the area of this donut region on the outside, we'll have to do 144 pi minus 49 pi, and that gives us 95 times pi. And then if we approximate this, if you do 95 times 3.14, we should get about 298.45 square feet. And that gives us a good idea of how much area there is there. And that's the benefit. I mean, this is nice in that it's not approximate. This is an exact value. However, the question I always ask is exactly what is it? We don't really know. We can get a nice estimate for it, and that's really helpful if we have to work with that area. All right, well, let's take a look at a couple more here. Problem 8. We've got a rectangle inside of a circle. Oops, rectangle inside the circle. There we go. So let's make the circle. and then the rectangle, something like this. And there's our diameter right there, is 10 meters, and this is 8 meters and 6 meters, and our shaded region is around the edges of the rectangle. Okay, so the key here is we want to find the area of the circle. So the key here is to recognize that if this distance is 10, that's the diameter, and that means that the radius is going to be 5 meters. And so the area of that circle is going to be pi times 5 squared, which is 25 pi. And then the area for the rectangle is going to be 6 times 8 meters, or 48 square meters. And so the area of the shaded region is 25 pi minus 48. And then we'll use the calculator to get a good approximation for that. Let's see here, 25 pi minus 48, about 30.5 or so, 30.5 square meters. Okay. I think problem 10 is similar. I think it's the same. Yeah. So in problem 10, we've got a circle. Oh no, it's the opposite. We've got a circle inside of a square. So here's a square. And I think we did see another problem like this a few minutes ago. Yeah, that second example that I did was a circle inside of a square. So on this one, this is labeled 14 centimeters on each side. Our shaded region is around the edges. Now here's the key to doing this problem number 10, is that if this distance is 14, right, that means that the radius for this circle is 7 centimeters. Okay? So we need to find the area of the square is going to be 14 by 14, or 196 square centimeters. The area for the circle is going to be pi times 7 squared, which is 49 pi. So that area of the shaded region, 196 minus 49 pi. Let's see what we get here. And that gives us just about 42 square centimeters. Okay, and that's number 10. And we'll look at, we'll look at a couple more here. Problem 12 is a little bit different. Not too bad, but it is a little bit different from the other ones that we've seen. All right, problem 12, what we've got is a rectangle like this that has half a circle in it, and then the shaded region is out here. And we know that this is 15 feet. We know that this is 30 feet. And so then we want to find the area for that shaded region. So what's happening here is the area for the rectangle, right, which is the exterior, is 30 by 15, which is 450 square feet. And then you've got this radius here on the circle, which is 15 feet. But it's not a whole circle, it's only half of a circle. Okay? So we want to do pi r squared and then divide it by 2. Okay? So let's see what we come out with on this one. So this is pi times 15 squared, and then divide that by 2. And so this comes out to be about 353.5 0.43 square feet. And then we need to subtract 450 minus that 353. And so our area comes out to be about 96.6, we'll say, square feet. Okay. So what was tricky about that one was that we had to cut the area of this circle in half because we only had half of a circle there. Okay, well, let's take a look at one more here. Problem 14. Let's see, I don't know if I'm going to be able to draw this very effectively. What we've got is we've got a big square that then has all these little circles inside of it. So let's see what we can do here. 1, 2, 3, 4, 3, 4. So you'll have to just sort of imagine that my drawing is a good representation of the problem. The shaded areas are everything except the circles. Okay? Okay, now that's not too bad. Let's see. And so this is this big square is 32 inches by 32 inches. So let's just get that out of the way. The area for the square is going to be 32 times 32, which is 1,024. Okay, so there we go. Now we've got to figure out, well, what's the radius for one of these circles? These circles are all the same. They're all the same size. There's 1, 2, 3, 4 of them. If this distance is 32 inches, that means each of these is going to have a diameter of 8 inches. Okay? Which says that the radius for one of these circles is going to be 4 inches. So that's the key to finding the area for one of those circles, pi times 4 squared. But then that's just one circle. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 16 of those circles. So let's calculate that. All right, so let's see here. We've got pi times 4 squared times 16. That's about 804.25 square inches. So now we've got to do 1,024 minus 804.25. And what do we get here? Approximately 219.75 square inches. Okay. Well, that's it for this handout. It's got an answer key on there. If you have any questions, if you get stuck, please let me know. We're just about finished with all the topics that we have to talk about. We've got one more assignment, and then for the week after Thanksgiving, I'll try to post a sample final along with a video review. So hopefully that'll help you get ready for the final exam. As always, if you have any questions, please let me know. Thanks.